Welcome to No Context Math, brought to you by Unlimited Curiosity. Today I want to quickly go through how to factor quadratic polynomials, and this is a good visual representation to teach somebody who may be learning this for the first time or who may have learned it but is struggling with it. So first off, just a quick reminder, what is a quadratic polynomial? It is a polynomial of the form ax squared plus bx plus c, where a, b, and c are all integers, and the highest exponent in the polynomial is a squared term, where we don't have to deal or worry about anything that is a cubed or to the fourth or what have you. So what do we mean when we say we want to factor a quadratic? Well, if you factor a number like 14, that's pretty intuitive, and most folks have learned and can tell you that 14 factors into 7 times 2. And likewise, 33 factors down to 11 times 3. Well, we can apply the same technique and say, okay, well, how do we factor x squared plus 2x plus 1? Because really, x squared plus 2x plus 1 for different values of x just represents a number. It's maybe a little bit more complex way of writing that number, but since it is a number, it can be factored down like any other number. And so I want to walk through what I call the X method of factoring quadratics, which is a little bit more visual than maybe you will have learned, but I found that it helped me when I was first learning this, and then after you get enough practice using the X method, most folks can graduate to performing all these calculations in their head and so forth. But this method really helps kind of teach you the basics of what's going on and what you need to check and so forth. So within the X method, there's 4 steps that you need to follow each time. You need to factor each end of the quadratic, which essentially then proposes a solution. You then need to cross multiply, need to add your terms to match the middle term, and check validate. And we'll see what all this means pretty quickly and pretty simply here in just a minute. So the first example, let's say we want to factor x squared plus 2x plus 1. Well, we want to visually use what I call the X method. And so the very first step is just drawing an X, which connects the left term top to bottom and the right term top to bottom. So you just draw an X underneath your equation. The next step is we want to factor each end of the quadratic. And so we want to factor the leftmost end and the rightmost end. Well, the leftmost end here is x squared, and the rightmost end is 1. So x squared, how can we factor that? Well, that's pretty simple. X squared factors into x times x. So we write that factorization underneath the x term. And then we want to factor 1. Well, 1 factors into 1 times 1, so we write that down underneath the 1, underneath the last term. And so you may not have realized it yet, but what we've already done is we've proposed a solution to be able to factor this quadratic polynomial, where our solution is, if we read it across the x horizontally, our first proposed solution is x plus 1 times x plus 1. And so we propose a solution. Okay, so now what? The next step is we want to cross multiply. And so we want to cross multiply from top left to bottom right, so x times 1 is x, and then we want to cross multiply top right to bottom left. 1 times x is also x. The next step is to add the terms with the goal that they match the middle term. So now we have an x, and this combines to 2x, and we see that these terms, when added, 2x matches the middle term, which implies that the original solution that we came up with of x plus 1 times x plus 1 works. But since it's math and mistakes can always happen, we always want to validate and check our work. So we take our proposed solution, and if we multiply it out, we should equal our starting polynomial. So multiplying this out, x times x is x squared, x times 1 is x, 1 times x is x, 1 times 1 is 1. We could simplify the 2 terms in the middle, and we now have x squared plus 2x plus 1. And we have just validated or verified that these 2 terms when multiplied equal our original polynomial. So the correct factorization of x squared plus 2x plus 1 is x plus 1 times x plus 1. Let's try another one. So let's say now we want to factor x squared minus 6x minus 7. Well, first thing we want to do is we want to visually use our x method, so let's draw our x. Next step is we want to factor each end to propose an initial solution. Well, one end is x squared, so that factors into x times x, so we write those terms underneath the x. And then negative 7 we can factor or write as negative 7 times 1. And so we write those terms under the negative 7 term. Next step is we want to cross multiply. So we have negative 7 times x equals negative 7x, x times 1 equals x. Next step, let's add up the terms and hope they match the middle. Negative 7x plus x is negative 6x. Good news, negative 6x here matches the term in the middle, so it implies that our solution of x minus 7 times x plus 1 is correct. And once again, always want to validate. So let's take our proposed solution, x minus 7 times x plus 1, and multiply these two binomials out. X times x is x squared, x times 1 is x, minus 7 times x is minus 7x, and minus 7 times 1 is minus 7. We can combine the two terms in the middle here, so x minus 7x becomes minus 6x, and we have validated or verified that x minus 7 times x plus 1 does indeed equal x squared minus 6x minus 7. So we have now successfully quickly factored this quadratic polynomial. Let's run through two more quick examples here. So this one is slightly more complex, though it's not too bad. You'll notice that we just now have a coefficient that is not 1 in front of the x squared term. But you'll see that we want to follow the exact same steps, which will allow us to successfully factor this polynomial. So the first step is we want to draw our x. Next step is let's factor each end to propose a solution. So let's factor 3x squared first. Well, we can factor 3x squared into 3x times x. So we write 3x and x underneath the 3x squared at different corners of the x. And now we need to factor negative 12. Well, we can factor negative 12 into 3 times negative 4. So we write both of those numbers underneath the negative 12. So now, once again, we have proposed a solution of 3x plus 3 times x minus 4. Let's take it further and see if we can validate it. So cross multiplying, we have 3x times negative 4 equals negative 12, and we now have 3 times x equals 3x. Let's simplify those terms, and here we will notice that we get negative 9x, which does not equal 5x. So what that implies is that our first proposed solution is not correct, and we need to try some more combinations. So the combination we just tried was 3x and x for 3x squared, and 3 and negative 4 to factor negative 12. Well, what happens if we just flip these negative 4 and 3? So negative 4 we'll put on the top, and 3 we'll put on the bottom. We have still factored negative 12 into negative 4 and negative 3, but we have just switched the order that we have placed them in our x, so to speak. So now let's cross multiply this new solution of 3x minus 4 and x plus 3. 3x times x equals 9x. Negative 4 times x equals negative 4x. Let's add up our terms, and lo and behold, 9x minus 4x equals 5x. This term matches our middle term, which implies that our solution is correct. Once again, let's validate that our solution works. 3x times x is 3x squared. 3x times 3 is 9x. Minus 4 times x is minus 4x. And minus 4 times 3 is negative 12. Adding our terms in the middle, once again, is 3x squared plus 5x minus 12, which means that our proposed solution of 3x minus 4 times x plus 3 is in fact correct and is the successful and correct way to factor our starting polynomial. Now, you'll notice that some of this is trial and error, but using this method is very quick and easy to be able to visualize and quickly check and run through different combinations. Now, let's try one last example. Let's say we want to factor x squared plus x plus 1. Once again, let's use our x method and draw our x. Now let's factor the left side and the rightmost term. So the leftmost term, x squared, factors into x times x. So we write x times x. And the rightmost side 1 factors into 1 times 1. So now we have a proposed solution of x plus 1 times x plus 1. Well, let's cross multiply. X times 1 equals x, 1 times x equals x, and adding those two terms together gives us 2x, which does not equal our initial and desired middle term here. So this tells us that x plus 1 times x plus 1 is not a correct factorization of this polynomial. So let's try another combination. Plus 1 can also be factored into minus 1 times minus 1, since negative 1 times negative 1 still, in fact, equals 1. So let's leave the x squared factorization the same and test it out and see what we get. Well, notice in this case we get x times negative 1 is minus x, negative 1 times x is minus x, and now our term is negative 2x, which still does not equal x. It turns out for this particular example, no combinations of factoring the leftmost term and the rightmost term will allow us to cross multiply and successfully get a middle term of just 1x. If you run through all the combinations and determine that we cannot successfully match up the middle term after cross multiplying, it implies that there is no more simple form to write this quadratic polynomial as, and this cannot be factored and is already in its simplest term. So as a quick review, we went ahead and we were able to factor x squared plus 2x plus 1 into this product of binomials, similarly for these other two equations, and we had learned that x squared plus x plus 1 is already in its lowest terms. I like to encourage people when they're first learning to use this x method. It's not a new way, it's not a different way of doing things, but I find it is more visually appealing to folks and allows people to see what is going on, become a little bit more intuitive with what their guesses are, and then ultimately, after a bunch of practice, you get good at it and you're able to do it in your head without going through all the steps and combinations. You can very quickly intuit what the correct solution is and so forth. So thank you for watching, and we will see you next time on No Context Math.